Hey, welcome to today's video. If you are into the machine learning, you have probably heard the term regularization. But what does it really means and why it is so important? So what is the regularization? So in the simple term, it is a technique used in machine learning to prevent model from overfitting. So overfitting happens when a model learns too much from the training data, including the noise and the random fluctuations, making it perform poorly on new, unseen data. So regularization helps by adding a penalty to the complexity of the model, essentially making it simpler and more general. So let's start with a basic linear regression. So in the linear regression, we try to fit a straight line to our data, typically by minimizing the sum of squared error between the predicted values and the actual data points. So here a simple example of linear regression without regularization. The model fits the data perfectly, capturing every fluctuation and noise. But notice how the line is overly complex and wiggle a lot. So this is a sign of overfitting. It works great on the training data, but likely won't generalize well to the new data. Now, what if we add a regularization term to our linear model? Regularization add a penalty to the loss function which we aim to minimize. For linear regression, this penalty is typically related to the magnitude of the model coefficient. So here's the lambda is the regularization parameter which control the strength of the penalty, right? The BI are the coefficient of the model where when lambda is large, the model is heavily penalized for large coefficients, leading to smaller and simpler model. So with regression, the model is forced to keep the coefficients small, reducing the overfitting problem. Now let's walk through the code where we compare the linear regression and rigid regression. We'll create a synthetic data set with 50 features and we'll add a noise to simulate a real world scenario where overfitting might occur. So we'll generate 100 samples and 50 features using NP random RND function. For our target variable y, create a linear relationship with a bit of noise added to make the problem harder for the model. Right? Let me load the libraries. So here x and y's. Uh, Next, we'll split the data into training and test set using train test split, right? And here we fit a simple linear model without any regularization and make the prediction. So here we use the mean squared error to evaluate how well the model is performing. This will give us the sense of how much the model is overfitting. Now we'll fit the rigid regression model with a strong regularization penalty. We set the alpha to 100, right? To apply, we set the alpha to 100 to apply strong penalty to the coefficients, right? Now we'll visualize the difference between the two models by plotting the prediction and coefficient. So let me run this. So in the first plot, we compare the true versus predicted values for both models. And the second plot shows the coefficient for both the model, which will clearly show how rigid regulations shrink the coefficient. So let me run this one. So as you can see, the with the linear regression with no regularization, and the difference is clearly visible with the rigid regression, and it's actually shrinks the coefficient to minimum, right? Now let's analyze the result. From the first plot, you can see how the red points, the linear regression, are further away from the ideal line compared to the green plot, the rigid regression. So this shows that the rigid help the model generalize better by reducing overfitting. And in the second plot, as notice how the coefficient for the linear regression are larger and more unstable, especially for the features that are highly correlated. correlated. On the other hand, the rigid regression has smaller, more stable coefficient. So this is clear sign of the regularization in action. Now finally, we'll look at the MSC values for both the model. Let me run this. As expected, the rigid regression has a lower mean square error compared to the linear regression, which indicate that regularization helps the rigid model generalize the pattern on the test data. So as you can see, the rigid regression perform much better in terms of a mean square error. This is because of the regularization prevent the model from overfitting and shrink the coefficient. So to summarize, today we have learned how regularization, especially the rigid regression, can help improve model performance by preventing overfitting, especially in high dimensional data set with noise. If you're working with more complex data, rigid can be a great way to improve generalization. So if you found this video helpful, don't forget to hit the like button.